Hey guys, it's Tamer, and I'm going to show you guys how I apply dependency inversion in my game. So what is dependency inversion? Dependency inversion is a great method to apply when you want to decouple your components. So say we have a main class called ship, right? The ship method, usually how you would go about this, is taking the input from what the user wants the ship to go and do, whether it wants to go left or right and move forward, okay? All of these processes, such as this, and also receiving whatever damage that the ship can receive, and a whole bunch of other dependencies, can make the game very inefficient and ineffective really quick, especially when you start building up a lot of the dependencies. Because what happens is once you start earning and getting a lot of the dependencies, your game is going to be reliant on those dependencies. And imagine if you have to change some of those dependencies, it can mess up the whole structure of the whole game. So what we want to do is apply dependency inversion so we can get a decoupled class to class relationship, which is very effective because we can change things at the lower component level without having to change the whole structure of our code. I'm going to go ahead and show you guys how this works with a diagram. So usually how you would go about this is without incorporating a interface for the abstraction. Usually how you would go about this is you would have the motor actually a part of the ship class, and the ship class would actually be reaching out to the dependencies like receiving input from the user, receiving the number of damage that it's currently receiving from the enemies, receiving what type of what type of enemy ships are nearby. I want to dive deep into the diagram and show you guys how dependency inversion works. So usually before actually applying the pattern dependency inversion, usually users would have the ship and the pirate ship motor v3 actually in one script. And this is inefficient and ineffective because when we actually have our main class going out to dependencies and checking them, whether users are moving right, whether users are moving left, how many damage is the ship currently receiving? Like if you're making that class have to go out and see what the dependencies are, it's inefficient because our components are not decoupled. And if we want to change something at the lower level, it could affect the overall structure of our code. So we want to make sure that our main class ship doesn't have to go out and do that, but instead is actually receiving our dependencies. Okay, so how do we do that? We go ahead and make a interface called iShipInput with the methods read input, rotation, and thrust. We go ahead and apply, in this game, we apply two controllers, the AI input and the controller input, where they inherit the methods from the iShip input interface. And you can see for the AI, it's going to be adjusting the way our ship moves randomly. And this is how we incorporated the AI type of feature. And then now say if the user just wants to use a regular controller, he will be able to move left or right accordingly to what key he presses. Okay. So this is where our controller is now, instead of having to check that in our ship. So now the whole purpose of all this to make the dependency version come true is all about being able to separate all of our component and code apart from each other. You can see that now our ship and our motor, instead of having to be in one class, are separated as well. You can see that this is going to be our main class, and this isn't actually going out to any of the other classes. This is receiving all of the attention without having to know how these even work. So you can see that in the ship, we attach the ship class to the actual ship object. And on awake, we're going to be creating and instantiating how we want our motor to work. But the first thing we want to do is make sure that we check what the user initially wanted. So we check whether or not the user wanted the AI to control the ship, or whether or not if the user wanted a normal controller, he can control the ship. So we go ahead and initialize the ship input to whatever one the user wants to apply. And then we instantiate the pirate ship motor with this ship input, as well as the ship settings. And what the ship settings do is has the turn speed, the move speed, and the AI, where the user will be like, you want to use the AI or do you want to use the normal controller? Right now it's false, so it's going to go to the controller. So when you have it as false, that's how it's going to be able to just assume that you want to use the controller in this inline operator. And then on update, we're going to keep on checking what way the boat should move. And since we apply dependency injection in the new pattern, this will be receiving those updates without having to go and check, simply by doing ship input dot rotation. And this is how we'll be able to check with its rotation that we inherited from our interface. And you can see this is the constructor where we initialized here in the ship. That's going to be receiving our ship input, one of these two, and then the ship settings. Okay, so let's go ahead and dive into the code. So I'm going to go ahead and start off with the ship. As you can see, this is very similar to how the diagram is. I made the diagram very clear and it just replicates everything that's in the code. So I'm not going to go over this for too long, but here we just kind of like a bootstrap method. We instantiated our objects right here in the ship. This is the script that we attached to the ship. And you can see whether or not the user in the file settings selected or not to use AI, and whether or not you want to move 25 or 30, etc. You can change all this in the GUI. We're going to go ahead and take those variables and then apply them and instantiate it to the pirate ship motor. As you can see here, ship input, and then the settings get applied here. And then on update, we're going to check our controllers and whether or not which one we're going to use. And then on pirate ship motor.tick, we just want to keep running this method inside our motor that will be receiving dependencies instead of having to go out and look for them. And you can see our dependencies here, like ship settings, turn speed, ship settings, move speed, ship input rotation, ship input thrust. It'll be just running on update and checking whether or not the user is going left or right, or whether or not the AI controller is going left or right. And this is how we're able to move the boat. This is our iShip input that is letting us do this type of abstraction. And these are the two controllers for AI and the normal controller. Okay, so I'm going to go ahead and run the game now and kind of show you how this works. But first, I want to show you how I applied the script on top of the object. So I went ahead and attached the ship script. And then after, I went ahead and created, since we did a scriptable object for the file settings, you can go ahead and replicate what I did here by saying, hey, come here, create ship settings. And then now you'll have another pair of settings, and you can adjust how fast you want to move or whether or not you want to use the AI controller or just a normal controller by not selecting. So I'm going to go ahead and in this example, just not do the AI. And then I'm going to run the game. So when I run the game now, it's going to go directly, the program is going to go directly to the ship, and it's going to instantiate a new motor object to the ship. And remember that this motor object is dependency injected, so it doesn't have to go out and do anything. It is just receiving. So now when I'm moving the boat with my keypads, it goes to the controller, the normal controller, and then it goes to the interface. And then motor is actually receiving these updates from the ship interface as well as the file settings, since the file settings and ship interface was instantiated when we created this with the ship script. So this is how we apply dependency injection in our game. And just for the flow and show you guys how this works, just for recap, I'm going to go ahead and open up that diagram one more time. So this, depending on whether or not we move left or right, when we instantiated the pirate ship motor V3 ship with the ship input, now we have the ship input in our motor, so we don't have to go out and find it. We can just be like, hey, so what's the current ship input thrust? What's the current ship input rotation? Ship settings dot turn speed, ship settings dot move speed. And this is how dependency inversion works. And this is why it's super efficient and effective on the processor. By separating our components out, we can make and save a lot of our processing power to make use of it in other ways instead of having to be so concentrated and consolidated in one area of the game, which is super inefficient and ineffective. So this is why we would apply the dependency inversion. I hope you guys all enjoyed this video. It's Tamer, and this was dependency inversion. Thank you guys so much. Have a great night.